Why hello lovely humans! Welcome to part 2 of Center of Mass Calculations, where we tackle non-uniform mass distributions. Woo, so spooky! Don't worry, it's not too bad, especially when we understand how to wield the equations because we actually understand what the symbols are telling us. So, the problem that I posed in the end of part 1 of Center of Mass is that now, all of a sudden, we have a box where we have a bunch of weight at the bottom, in fact 75% of the total mass, and in the top of the box is 25% of the total mass. Let's deal with the same dimensions of our box. So our box has a height of h, dimensions in quotes, aka just variables, and our box has a length of L. Again, our origin for our coordinate system is going to be the bottom left-hand corner of our box. And horizontal is going to be x, and vertical is y. And so the point at which we can say the mass is kind of broken into chunks is at y equals h over 2. The very bottom, we have y equals 0, and at the very top, we have y equals h. Okay, so what is nice about this particular setup is that it actually allows us to just separate the integral into different pieces. It also allows us to ignore the x direction because in this case, the mass is only different in the y direction, and in the x direction it's still uniform. So we can just say that the center of mass location in the x direction is L over 2 per usual. No problem. Okay, and so in this case, what changes is the density. So it'll help to start by looking at how the density changes. So from 0 to h over 2, the density, which we'll call density 1, is just 0, whoopsies, oh my gosh, that is a wild looking 7, 0.75 of m total divided by the length of that section, which is just, whoopsies, h over 2. And then from the top half of the box, we have h over 2 to h. The second density is 0.25 times m total divided by the length of the second half, which again is h over 2. And so now we're like, wait a second, if I just break up my center of mass integral into 2 chunks, I can basically do the exact same thing that I did for uniform mass distribution. Heck yes, you can. I gave you a fairly straightforward problem so that we can make sure that we understand what we're doing. So now I'm going to draw a little area for us to do center of mass calculations. So y center of mass, we'll just start from the general formula. So 1 over the total mass from 0 to m, y dm. Okay, and now we break it up into chunks. The first chunk is from y equals 0 to y equals h over 2. So the integral from 0 to h over 2 of y times density 1, because dm is just the density times dy, since we can neglect the x direction. Density 1 times dy plus the integral from h over 2 to h of y times density 2 times dy. Look at that! That's not so bad. And so now we will plug in our values for the densities. 1 over m, bracket, integral from 0 to h over 2, y times 0.75 m divided by h over 2 times dy plus our second integral, h over 2 to h times y times 0.25 m over h over 2, that's a tiny h, times dy. Boom! Not so bad, right? So now you just evaluate each integral independently and simplify. And what you should get is that the center of mass in the y direction, can you see that? I think so, is 3/8 h. Check it out. So all of a sudden, instead of being at the halfway point, the center of mass has dropped down. And that is where we get to see the weighted average in action. So when our density of the material is not linear, it changes the location of the center of mass, which is what we would expect. So what I want you to do is I want you to finish working through this integral to give you some practice dealing with integrals and tackling real-world problems, and just make sure that you get this result. Please let me know if you have any questions. In the next few episodes, we will be building up to calculating tipping force for different types of objects. Let me know if there are particular objects that you're interested in. I know trapezoids. How do you make a trapezoid with your hands? Whatever. Trapezoids are really common in parkour athletics, so I'm happy to tackle a trapezoid. I'll probably start with a box. Bloop! I can do the box with my hands. We'll start with a box, and then if you want to tackle different types of objects, let me know. And of course, if you have any requests for other types of math topics, please just let me know by leaving a comment on one of my videos. Cool. Thanks very much for watching, and happy mathing, friends. Bye!